Hi students, this chapter we are going to look at electrolysis. So what is the definition of electrolysis? This is the decomposition of a compound by electricity set up in an electrolytic cell. So generally this compound, we call it an electrolyte. Okay, and remember, because I use electricity, it must be able to conduct electricity. So what substances can conduct electricity? Again, this is your ionic compound, must be in molten or aqueous state. Okay, if you cannot remember ionic compounds conducting electricity in molten or aqueous state, please refer to my chem bonding videos. Okay, it cannot be metal, because metals, yes, they can conduct electricity, but they are elements. Elements cannot be broken down further. Okay, so in an electrolytic cell setup, right, we will have two electrodes. Okay, and then we will have batteries connected to it. So with the batteries connected, I always like to draw the short end. The short end is where your electrons flow out. Okay, so when your electrons flow out, this part is all, this electrode is all negatively charged. And the opposite one will be positively charged because your electrons flow away from it. Okay, so this part over here, what happens? The reduction is going to take place here. Why? Because reduction is gaining electrons. So you can see the electrode gain electrons because your electrons flow out from the battery. Okay, and then we always label it as the cathode. So I also remember it as red cat. Okay, and then on the opposite side, we will have the oxidation is losing electrons. You see your electrons are lost, is flowing away from the electrode. Okay, oxidation is loose, and we will name the electrode anode. Okay, so I remember it as an ox, red cat. Please remember this. Okay, so like I tell you, in an electrolysis setup or electrolytic cell setup, we have the battery. That's the positive and negative terminal. Okay, so what happens? It supplies electrical energy for chemical reaction to take place. So energy conversion or energy changes from electrical energy to chemical energy. Okay, electricity flow out this way, and then chemical reaction takes place here. Okay, the electrodes must be conductors of electricity. We always use graphite or metal electrodes. Okay, so graphite is an inert electrode. Okay, remember graphite have delocalized electron between the layers, is the inert electrode, and then it doesn't take part in the reaction. Okay, when you use conductors such as metals, these electrodes are reactive and they will take part in the reaction. Okay, cathode attracts the cation. So because this plate is the negative plate, it attracts the cation. So cat attracts cat. Okay, cathode attracts the cations. Cations are discharged to molten state. So what do we mean by discharge? Means these positive ions will form something that is molten. Later we will discuss this. Okay, cathode is negatively charged as per discussed. It gains electron from the negative end of the battery, and then reduction is gaining electrons. Okay, so it becomes neutral. So reduction and cathode. Okay, red cat. Anode attracts the anions. So the positive electrode is the anode. It attracts the anions. Okay, anode is positively charged because your electrons are flowing out, and it loses electrons. It is connected to the positive end of the battery. Okay, oxidation is losing electrons. So oxidation occurs at the anode. Okay, these anions will ultimately lose the electrons to become non-metal molecules. And ox, red cat. Okay, please remember this. Okay, electrons will flow from your anode to the cathode. So let's look at how your electrons flow again in the circuit from the anode to the cathode. Okay, so this picture, let's use an example. For example, now if I have an electrolyte, which is my sodium chloride, that is molten. Okay, so based on your battery, the short end, this whole part is negative. This whole part is going to be positive. Okay, this whole part is negative. The cations attract to the plate. So the positive ions get attracted to the plate. Okay, and they will gain electrons. So what are the cations that is in the electrolyte that I'm trying to break down? Is my Na+. So it will gain the electrons to form sodium metal, the molten metal. Okay, so reduction is gain and red cap. Right, so your cathode is the negative electrode. Reduction takes place to form molten sodium. Okay, and then another example, at the anode, what's going to happen? So anode attracts anions. And what will happen to the anode and ox? So oxidation is lose the electrons. Right? So what happens? You can see your electrons flowing out. And what's the reaction that takes place here? What's your negative ions? Cl minus. Cl minus will form Cl2 naturally. How do they form from the minus? How do they form Cl2 neutral? They will add electrons over this side. Okay, so when they add electrons on the right side, this part we are losing the electrons. Right, oxidation is lose. Oxidation takes place at the anode because an ox, red cap. Okay, inert electrodes do not take part in the chemical reactions. Example, platinum. Okay, so this is the only metal that's inert. And graphite. Graphite, delocalize electrons between the layers. Okay, so they do not take part in the reaction. They will just provide a surface for the chemical reactions to take place. Okay, so they do not react with the electrolyte. They do not react with the product. They just act as a surface. Reactive electrodes will take part in the reaction, such as copper, silver, any metal other than platinum will take part in the reaction. Okay, electrolyte, it must be molten ionic compounds, okay, or aqueous solution. So aqueous means dissolve inside water. Okay, and your ions, because they dissolve, they dissociate. So they are mobile ions that act as charge carriers to conduct electricity. Okay, strong electrolytes, complete dissociation. We have your strong acids, your salt solution. Weak electrolytes are partial dissociation, like your weak acids. Non-electrolytes means if I put pure water inside, H2O, water only without any ions, okay, covalent compounds. These are, they share electrons. So there's no ions, there's no delocalized electrons to act as charge carriers to conduct electricity. So they are what we call non-electrolyte.